Welcome. Continue our moment of inertia calculation for steel structures. Question 94. Today I am covering two channels. See, first question. The cross section, these are all required for steel structures. The cross section of a column consists of two channels ISMC 400. You just see the number here. Otherwise it is not required. 400 placed back to back at a clear distance of 180 millimeter. Okay. Sometimes they can give line diagram for you. See, when two channels are there, see, this is a two channel. Line diagram this way. This is called placed back to back. See. Now, or sometimes channel can be placed like this. This is not called back to back. Some people call this as face to face. See here, both are outwards. Face to face or toe to toe. This is our second round. Some difference is there. So this line diagram can be given. Or sometime in the engineering mechanics question, they will tell this clear distance is 180 millimeter. Okay, then properties for ISMC. See, this total depth they will not give. In steel structures, understood. ISMC 400 means the total depth is how much? See, the total depth H is 400 millimeter. Understood. 400 millimeter. That number only is the depth. But if the question comes in engineering mechanics, sometimes they give the H also. Why? Because people may not be knowing that that number corresponds to depth. Therefore, okay, if you are studying steel structures, this is known for you. Find moment of inertia about centroidal axis as usual. Okay, start. Properties given here. I will write one thing. First, I will write properties of a channel. See, ISMC 400. This is called breadth of flange. It is given how much? 100 millimeter. See, this is thickness of flange. It is given there. The 15.3 millimeter. This is thickness of web. That is 8.6. But actually, this question, that thickness of flange and thickness of web are not required. They are required when you go to steel structure for other reason. Some other reason you require, but breadth of flange may be required. Then, see, correct, clear. X axis, Y axis, its own centroidal axis. Now, see, this is perfectly symmetrical. If this is H by 2, this will not be given. Understood. But this way, centroid is the, there is no symmetry here. So, centroidal axis will be little this side. This distance is called centroidal distance of YY. In steel structures, it is called centroidal distance of YY. Engineering mechanics, they can give a sketch for you and tell this as X bar. Anyway, sketch will be given. Okay, then see all the property given there. I copied the required property here. Okay, start. One channel placed here, one channel placed here, 180 mm clear distance. See, divide in two parts, part 1, part 2. See here, this is centroid for the component. So for this component, see here, this G is this G, G2. Here is turned, see, turned here. This G is here, G1. Okay, now correctly mark XX, YY. Make a note that due to symmetry, when I put a ink always it happens. Okay. You write a note. Whenever symmetry given, you don't have to locate XX and YY. Why? Directly mark it. You locate XX or YY only when there is no symmetry. So, directly due to symmetry, XX will come here. See, this is your XX axis. Okay, take further. Okay, over XX, sufficient. XX. Now, see, this total depth is 400. You can see here, H 400. So, if you want this distance, this is 200, this is 200. If you want it, 200. Then, YY, see, this is center, see, this is YY for the component, but for these two channels together, centroidal axis will come exactly here due to symmetry. See, this is YY without disturbing project here. See, this distance and this distance required sufficient. 180 means 90 and 90. This distance, if requirement is there, 100 mm, it is there. Okay, start now. So we will always find area because in steel structures, area required. 6293, see, part 1, part 2. I will not tell you, you have to write it. What I am doing is for one part, other part you do yourself only. See, 6293 is the area of one channel multiplied by 2 will give total area. Calculate in mm square. Then I about x-axis axis. There are two channels are there. You can consider any channel. Do one thing. Consider the channel which is placed as per a property. That is this channel. Better. See here. We want I about x-axis. First I about its own centroidal axis. Parallel to x-axis. This axis. I about this axis is nothing but I about this axis. How much? 15082.8 10 to the power 4 plus area into centroid G2 lies in the x-axis, so 0 square. See, then multiplied by 2. See how that is placed. Same, see once again here, once again same Ig plus 0 square into 2. Get the answer. Okay, over. I about Yy. Now be careful. I about Yy, be careful. Something is there. Start. First come here, any one channel, I think better this one. First I about, see, its own centroidal axis here. This axis. I parallel to Yy. I about this axis is, see, this axis, that is how much? 504.8 10 to the power 4 plus area into from centroid G2 to Yy, this distance square. That distance square is, see here, 90. It is 90 plus, from here to here is 90, from here to here, this distance is this distance. See here, it is given as, I forgot right here. See, also CYY given, how much CYY given? 24.2 millimeter. I forgot right here. It is required 24.2. So 90 plus 24.2, that distance whole square will give I about x, y, considering this channel. Identical here, see here once again same I, y, same a square, see this distance plus this distance is this distance. So multiplied by 2, you get I about y. This is question 94, cross section consisting of two channels placed back to back. Now do one thing, just to save the time also counts. I will give next question, 95. Single stretch, see here. The cross section of a column consists of two channels, ISMC 400 only I will take to save the time, placed back to back at a clear distance of, I will change the distance, say clear distance of 210 millimeter, just for a change. So therefore, this is 210 now. 1 minute, later I will put here, 210 millimeter. Then, 2 meter, there are two flange plates of 210 plus 100 plus 100 is 410. 450 mm by 20 mm, comma, one on each flange, given in the question. Okay, then question is find, save the time here, no time right here, I about xx and I about yy. Right. In the question, property is given, same property. I am not changing it. Why? Same section. You take this as independent question. Don't mix up. Now see, cross section will change. Or if they want this center line diagram, see how they will give. One channel they will give here. One more channel they will show here with a gap of how much? 210 millimeter. Plate they will show like this. See, they will show plate like this. And plate will go beyond the flanges. Why? I will tell you now. Okay, now start. Okay, that is same. So this is removed now. I will remove unwanted here. The cross section in millimeter. Okay. Y, later we will put it. Okay. Properties same. Okay, now see, as per question, there are two channels placed back to back. Okay. Then along with that one, two plates. How two plates? 450 by 20. See here. This gap is 180 millimeter. See here. This is 180 millimeter. If it is 180, This is 180. You make a note if you want. Make a note. This is 180 plus this width is 100. This width also 100. So 180 plus 100 plus 100. 100 plus 100 is 200. 200 plus 180, not 180, how much it is? 210. I changed it, question. Question changed, 210. So 210 plus 100 plus 100 is 410. And they told plate is width 450. Means your plate has to come outside. See, you will project outside. One plate here. Show the plate here. Thickness, they told two plates are there. How? One on each flange. So one plate here. See, one plate here. Little neatly I write. One plate here. And one more plate here. This two, 1 and 2 I'll put later. Okay. First I'll put the plate. Thickness is 20 mm. It is more than other thicknesses. See, this way, come here, same way. This all I'll put later. Okay. See, little projection is there. Projection is there. See. This is the cross section. Okay. Somewhat to scale. Okay, little more it became, it will make lesser. Okay, now okay, I think. Okay, now okay. Don't worry about other things. Now, see, dimensions. This is 100 mm. Actually, that 100 is not required. Okay, now you know it. See, 100, this gap is 210. See, this gap is 210. Okay, now, for the plate they told, width of plate is full width of plate. How much it is? 450. Thickness is 20. I'll check the camera once. If it is not visible, I'll move the camera. Thickness is 20. And this depth is nothing but this depth h is 400. See, this is 400. 400. Therefore, I have no space there. I'll mark here. The overall depth, see, the overall depth, full depth here will be 400 plus 20 is 440. Now, I will take the channels as 1 and 2. It is your choice. Okay. I will take this channel as 1, this channel as 2. Okay. Disturbance is there. This channel as 2. This plate I will take 3. This plate I will take 4. Now, see the centroid here. G1, G2, same as last time. For the plate, this centroid, that is what, G3 will be here, blowing. Okay. This is a problem. When I put more ink, it always happens. Okay. Okay, I'll manage. Repairing in this pen is difficult. Okay, see. This is your G3. Same way, this is your G4. Okay, now, again perfectly symmetrical. So, once again, this is the x-axis. So, if it is 440, this distance and this distance will be half of 440 is 220. And perfect symmetry, y come here. This is y axis. Say, okay, I'll shift that centroid here so that it looks correct. See. G4. Okay. This is your y axis, and you can do one thing now. The y axis from here to here and here to here, and see the full width is 210. So each of them will be 105 and 105. 105, 105. This is cross section. So two rectangles, this we have done it earlier. Start once again. First area. I will do for any one of the channel 6293. Multiply by 2, not over, plus further, see, plus. This is for into 2 because why? You consider any one of the channel, you write here, one of the channel into 2 plus plate. 450 by 20 is the area of the plate. 450 by 20 is the area of the plate. That also multiply by 2, you get the answer, area in mm square. Okay, next. I about x-axis, see here. Come here, any channel will do. This channel is better because this channel is placed exactly same way. I about its own centroidal axis, parallel to x-axis. That is this axis 15082.8 10 to the power 4, this is to save the time only, plus area 6293 into centroid G2 lies in XX, so 0 square into 2. Not over now, plus into 2 because you do for one channel identical for this one, multiply by 2. You write here, this is for one of the channel, then into 2. That much I am writing so many times earlier, plus. Start here. This is G3, not fully visible. Okay. First, I about its own centroidal axis. See, this axis. That is 450 into 20 cube by 12. 450 into 20 cube divided by 12 is IG. I forgot to check the camera for the top dimension. I think there is no problem. Yes. Visible. Fully visible, no problem. Okay. See, first I about its own axis. 450 into 20 cube by 12. So nobody should ask me, sir, what is its own axis? Question number 95. Now if somebody will ask, sir, what is that I about its own axis? Then don't study from me. Plus area. 450 into 20 is the area. See, into, see, your centroid of the channel lies in XX, so 0 square, but this centroid is outside XX. From centroid G3 to this axis, this distance square is 220 minus half of 20. Half of 20 close whole square. Whatever you get, that is for that plate, identical for this one, multiply by 2, calculate the answer. Okay, now, I about YY axis. Once again, start here. I about its own centroidal axis here. See, parallel to YY. That is nothing but this axis. 504.8 10 to the power 4 plus area into from centroid to YY. See, this distance square is 105. It is 105. That remains same. See, 105. See, from here to here is this distance square. 105 plus from here to here, this distance is this distance 24.2 whole square multiply by 2. That will give for 2 channels. Plus I about YY for the plate. First I about its own centroidal axis. Parallel to YY. 20 into 450 cube by 12. 20 into 450 cube by 12 is IG plus area. 450 into 20 is the area multiplied by, see, multiplied by centroid of the plate lies in YY, so into 0 square. That also multiply by 2. Or note here, when you do IXX, channel centroid lies in XX, 0 square. Plate centroid lies outside, so distance square is there. When you do I about YY, channel centroid lies outside, so distance square is there. But plate centroid lies in YY, 0 square. More than this I cannot explain. Okay, now question number 95 over. 96 and 97 are identical to this question. Only change is the 2 channels are placed face to face. Some see, when it is back to back, I told the distance square is what? 105 plus this distance. But it will change for the next question. And for next question, instead of ISMC 400, I will go for ISMC 350. Given in the question, I will give it. I will change the properties. Why same section always? 350. Okay. The cross section of a column consists of 2 channels ISMC 350 placed not back to back, placed face to face. See, face to face. Or make a note here, instead of that way, some people write some other way. Instead of face to face, they tell toe to toe. Both are same. See, one person standing here looking this last time, see, one person looking that side, one person looking back to back. Now they are facing each other at a clear distance of some number, say 190 millimeter. There are, no, 190 millimeter. That's all, this question. That's all. Okay, now find IXX, IYY properties for ISMC 350. Breadth of flange will change. Breadth of flange 100. Breadth of flange is same, I think, most probably. Okay, I'll do one thing. ISMC, I'll go for 300 so that breadth of flange is lesser. Okay, 300 I'll go for. 2 channels ISMC 300 for a change. So the properties of ISMC 300, see this I have to see IES handbook and write, so I will write it. I will write it. Question number 96. See, the question is cross section of a column consists of 2 channels ISMC 300 placed face to face at a clear distance of how much? 190 millimeter. Okay. Now, or sometimes they will tell you as shown in figure. See, 1 channel here, 1 channel here. Line diagram. Okay. Find IXX, IYY. Properties are given. Okay. See, draw a neat sketch here. Now see, I will take this is 1, this is 2. See, this is 190 is the clear distance. This width of flange is here, see, 90 mm. As for ISMC 300, this is 90. The thickness of flanges are not required. And depth h equal to 300, see, depth h equal to 300. Now, perfectly symmetrical. So, this is your x-axis. X-axis. So if you mark distance from here to here and here to here, it is total 300, 150, 150. X-axis, 150, 150. Now YY will be exactly here. See, YY is here. Now we require this distance sufficient. See, you can write full also. See, this is 190, 190 by is 95, 95. Or you can do one thing, this distance will be, see, if you want to understand, that will be total 370. So 370 by 2 is how much? 170, 180 is 380. 175, 370 is 185. Okay. 185, 185. Correct? 36, correct. 185, 185. Your choice. Start. First, area. See, however you place the channel, properties are always given like this. Understood? In all the handbook, in everywhere, not only in India, everywhere, when they give property for channel, they show like this. See, if you want to refer this channel, see, if you refer this channel, it is inverted. So do one thing, refer this channel. If you want this one, you have to turn it. See, how you are going this way, that you have to go this way. But if you refer this channel, yes, correct. Same orientation. Okay, start. First, area. Area of one channel. How much? 4564. Down I will write here. Area, space I require. 4564 is area of one channel. Multiply by 2, get the answer. Area over. IXX. See here. Start. You consider this channel now. Why? Exactly same way placed. See, I about its own centroidal axis parallel to XX. That is nothing but this IXX. 6362.6. 6362.6. 10 to the power 4 is IG plus area is 4564 is the area into from centroid G1 to XX. Oh, centroid G1 lies in XX, therefore 0 square. These are all told 100 of times. This is for one channel. Identically placed, multiply by 2. See, you cannot multiply by 2 if the channels are like this. This is not symmetrical. See, symmetrical means if this is looking that side, that should look this side, then only it is symmetrical. Okay, get the answer. IYY, see here, very important. First I about its own centroidal axis, see here, this axis. This IYY is nothing but this IYY. How much? 310.8. 310.8, 10 to the power 4, IG plus area is 4564 is the area, 4564 is the area into, see, from centroid to YY, this distance square. Last time, see, it was 95 plus something. Now, no, this distance square is 185 minus, see, from here to here is 185. Subtract only this distance. This distance is this distance 23.6. 23.6 whole square. Then multiply by 2 for 2 channels. You get the answer. Now, make a note here. Or, sir, suppose I do not write 185. See, suppose this 185 is not there. What you can do? When you want this distance squares here, it is 95. See, both are same. It is 95. See, 95 plus 90. That will give you from here to here minus this distance is, that is only 185 minus 23.6 square. Both are same. Make a note. Okay. This question also over. Now, last question. Today Sunday, lot of hectic activity for me. So, 4 questions sufficient today. See, 97. This time also I will do one thing now. Like last time for 2 questions, I maintained same channel section, ISMC 400. Now for these 2 questions, to save the time, properties are given. See, the cross section of a column consists of 2 channels, ISMC 300, placed face to face at a clear distance of, not 190, I will change it, clear distance of 90 plus 90 is 180, clear distance of 220 millimeter. I will tell the reason why. 220 millimeter and 2 flange plates. Now be careful language. 2 flange plates, 400 mm by 12 mm on each flange. See, on each flange. Over. Find IXX, IYY. Properties are given in the question. Now, very important. See, 2 channels are placed back to back this way. There are, see, last time I told you 2 flange plates, 1 flange plate on each flange, means total 2 are there. So, last time all 1 plate here and 1 plate here. But this time there are 2 plates here and 2 plates here. Now what you do is, see, when small note you require, see now, or rough sketch you write here, see, this is the channel. This is the channel, placed back to back. 1 more channel is here. See. Now, remember, this width is 90, see there, 90, this width also 90, this gap is how much given? 220 gap. This is 220 gap. So, from here to here, it will become 220 plus 90 plus 90. 90 plus 90 is how much? 180 plus 220 is exactly 400. And they told plate is 400. Oh, that means this time the plate will correctly fit here. See, last time it was having projection, this time. But actually remember, each flange 2 plates. See here. Each flange 2 plates. And how much plate width? 400 by thickness is, this is 12, this also 12, this is 12, this also 12. This is a section. See, if I tell total there are 2, 1 on each means one there, one here. But I told each side 2. I'll give 2 fruits and 2 people I will tell, you take it, 1 for each person. 1 fruit for him, 1 fruit for him. This time not that way. I am giving 2 fruits for each person. So here 2 plate, here 2 plate. Now one note you have to write. Note. See, later this will be connected by bolts. Bolts, welds, all, you don't bother here. Now, you need not waste time considering 4 plates. See, this is a rectangle, both are rectangle. Therefore, you make a note here. To save the time, you take 1 channel here. See, 1 channel here, 1 more channel here. And then you take just 1 rectangle here and 1 rectangle here. And for the rectangle, the thickness of each rectangle will be 12 plus 12 is 24. This is also 24. Therefore, even if 2 plates are given for a calculation, 1 plate, thickness is not 12, thickness 24. Okay, now I'll remove all this one now. So to save the time, you write all the statement you have to write. See, channel remains same, 300 only, no change. 300 only. Now, this I will remove now. I have to put the plate now. See. Okay, I'll put the plate. 1 and 2 I'll write later. This all I'll remove. Okay, see now. See, 2 plates are there on each flange, but for calculation purpose, you take just 1 rectangle of thickness equal to 24. Here also, thickness equal to 24 to save the time. Both are same. You don't have to waste time for both. 24, 24. Therefore, the total overall depth will be 300 plus 24 plus 24 is 348. Okay, now width of plate, somewhere you are right, it is 400. Just a minute. Every time I write upper side, I get doubt. Out of camera or within the camera? Oh, very much within the camera. Recording is on. Okay, now exact scale is not maintained. The slight tapering, this is actually, okay, some people are there who will comment for these things. Okay, now start. See, I will take this channel as 1, this channel 2, this plate somewhere here, this plate 3, this plate 4. Okay, start. Now, perfect. Now centroids. See, G1, G2, same as last time, and G3 will be here. See, G3 here and G4 here. Start. XX. Perfectly symmetrical. This will be XX. Again, this is YY. See. Next time I will do a question when plate is there only on one side. Next class I will do it. YY. YY, YY. Okay, now, see, they told, see, now this distance is, see, correct, clear, there is no plate right there. See, I write all dimensions here. See. YY, I'll put, see, this is YY. YY, okay. See, this width is how much? 90. This gap is, how much gap? That is 220. 220. This is 90. Therefore, your YY distance, see, when you write YY, you can do one thing, you can extend the YY here. When you write YY here, this distance and this distance you require, see, 90 or total for Y. 90 plus half of 220 is 200. 90 plus half of 220 is 200. 200. Or why that much? See there, total 400, half is 200. Okay, over. Now, area. Now this all I remove now, unwanted. Okay. Start. Area. First for channel. 4564 area of one channel into 2. See, I write area here. Space problem is there. See, area. 4564 is area of one channel into 2 plus plate is 400 by 20, or not 20, 24, that also into 2. Okay, over. I about x axis. Come to one channel. Same repetition. I about its own centroidal axis, parallel to x-axis, same axis. This I is, this I, 63, 62.6, 10 to the power 4, plus area into centroid lies in x-axis, 0 square into 2 will take care of other channel. Now, plus I about its own centroidal axis, see this axis. 400 into 24 cube by 12. 400 into 24 cube divided by 12 is Ig, plus 400 into 24 is the area into, see here, correctly, distance required into, see, I forgot right here, if it is 348, each of these extreme distances will be, how much? 348 by 2 is 150 plus 24, 174, 174. Correct? Huh? Yes, 174, 174. So, from centroid G3 to XX, this distance square is 174. This is all explained for you. Minus half of 24. 24 by 2 whole square is for one of the plates. Multiply by 2, you get for other plate. Calculate the answer. Now, I about YY. First about its own YY axis, its own centroidal axis. This axis is nothing but this axis. 310.8, 10 to the power 4 plus area into from centroid to YY, see, this distance square. That distance is 200. See, it is 200 minus, see, this is 200 minus this distance is 23.6. That one to be squared over into 2 will give I about, or you can do one thing, see, or 220 by 2 plus 90 minus this distance is 23.6 whole square. That is for what? 2 channels plus plate. I about its own centroidal axis. 24 into 400 cube, 24 into 400 cube divided by 12 is Ig. I will not explain now why. Plus 400 into 24 is the area into, I will not tell anything now, G3 lies in YY, 0 square. 0 square multiply by 2, get IYY. So once again here also, see now, when you do I about XX, channel centroid lies in axis 0 square, but rectangle plate centroid lies outside XX, distance square is there. When you do I about YY, channel centroid lies outside YY, distance square is there, but plate centroid lies in YY, 0 square. Okay, this is question number 94, 95, 96, 97. Next class is 98. I'll make a note here. Next 98. Okay. This over. I can do one more question, but today being Sunday, I took a lot of classes. Now feeling tired also, but still I decided every day I am uploading class. You wait for a little more time. I am planning to upload further more classes. Not now, little later. Okay, now study everything. Title will be today channels with or without plates. 2 channels with or without plates, or without or with the plates. Next time some new part will be there. So another 2 or 3 classes required for the steel structures part. It is useful for steel structures. Once again remember, you should study from part A. This is part C, I think today. I think it is part C. I don't remember now. In the title you can see it. But remember, you have to start from part A, not directly from here. Where I told everything. What is RSJ, what is channel, what is angle, T section, how properties are given, what is the principle, all I told earlier. Okay. Next class we will meet. Thank you.